Hi everyone. Today we are we will be talking about MLOps. So before I talk about MLOps, let me give a brief overview on what deployment is and why it's done. What's the motive, and what's the actual process behind it. Okay. Okay. Let's say you have developed a website and hosted it on remote server for people to access. Let's say the initial version has features A, B, and C. And now, over a period of time, your users start reporting bugs, and they will also notice that there are a few errors as well, and they might also ask for a new feature. So when these things accumulate, a developer is asked to solve them, to either create a new feature or solve the bugs and so on. So yeah, before I talk about this, so it's almost never a good practice to directly log in into a remote server and directly make changes there, because when you do that, there's a chance that you might crash the application, and there's no restoring the things back because you're not tracking the changes what you've done. So it's almost never a good practice to make changes in the remote server. So the a standard practice is that you make changes locally. So a developer, when he's assigned, he experiments here locally and then makes changes. And then when he sees everything is fine, he'll push the code to the code repository. And here, when he pushes it, CI/CD YAML file will trigger. So what this does is this YAML file defines a set of actions to do. So when we're saying that we want to solve a certain set of bugs or to add a new feature, let's call that feature D. When you're adding a feature D, uh, you want to make sure that you're not messing up on the already existing features, which are A, B, and C. And also when you're solving a particular bug, you want to make sure you're not creating more bugs at the same time. So for that, you can just in the YAML file, you can just mention a certain set of tests that you want to do, and then when all the tests have been passed, this you can mention it in the same YAML file that you want to log in into the remote server and update the code there with whatever changes you've done. So this is a regular deployment cycle or a DevOps cycle. This and nothing much changes here when we talk in terms of machine learning. It's just that the file size that you have and the data and the model files that are there, those are the ones that ask for a new branch called MLOps. So this talk will be divided into two parts. So the first part is where we version control our data and code, and the second part is where we talk about machine learning in production or deploying the models into production. So yes, so the first part, version controlling code and data. So the traditional software. So when I say traditional software, it's the programming logic that we write. So whenever you want to design a particular module, uh, you write a function with a certain logic. So for example, if you want to make a calculator, you write your logic here, and if you want to do anything, if you want to make a BMI calculator app, you'll write a logic. That's because you know that there are only finite set of inputs and outputs, and you know the actual logic behind it. But when it comes to, let's say, identifying a human in an image or identifying a ball, and these things they become more difficult. Let's say you can't just write rules for things like object detection or detecting intent behind a particular movie review. These things become difficult. For example, let's say you have a man holding a ball, and then you write a rule saying whatever is circular, that can be a man. So that fails because you already have a ball which is circular, and you have a man whose face might not be circular. And it's also possible that the image, when it's taken, the human is in the corner of the image, and so on. So this is where we don't go with logic driven software development, but we go with data driven software development, which is also called software 2.0. So here, instead of logic, we go with a machine learning model, and instead of code, we use training data. So machine learning model exploits or leverages this training data to learn implicit details on what it should look for. So this is essentially software development, and the problem between migrating DevOps from software 1.0 to 2.0 is that you have huge files here. So the training data could be in GBs, and same goes with the ML model. But here, if you see, these are just logics written in various programming languages, and they could be in KB. But here you're talking about GBs, and obviously Git doesn't support large files. And another thing is that machine learning is an experimental field. So you don't know what are the optimum set of parameters. You have to experiment and find them out. And also data keeps refreshing every now and then. So let's say this data has been collected over 2019 and data V2 has been collected over 2020. And so these features, so you change something in the script and you generate these features in the pre-processing script, you generate them. And now you change the parameters and you get a lot of different models. Now, what happens here is that you end up maintaining an exhaustive list of logbooks for every possible combination. However, let's say if you miss adding any detail into the logbook, you're essentially losing out on the information. So let's say this model is performing better, but you somehow forgot where this is coming from. Is it coming from V2 or V1, or is it coming from which of these 4 features? So this is a very tedious process, and for that you need to have a version control for sure. It's since Git doesn't support, we cannot just ignore these large files. Even they have to be version controlled. And as I said before, Git doesn't support version controlling large files. So that's where DVC comes into picture. So DVC does what it says, or what the name stands for, data version control. So they do just that. So they don't even go for code version controlling. So they'll just leave that to the Git, and they take care only about data. So I think this image might help you better to understand what's happening, how DVC integrates with Git. So it doesn't work alone, it works in tandem with Git. So let's say you have a 2 GB data file. When you give this to DVC, it processes it and generates a small metadata file, which could be less than 100 bytes. And this small metadata file is given to the Git. So now Git tracks both code as well as the data, metadata. So whenever you want the data, you just use DVC. You go to DVC and type DVC pull. So DVC pull will eventually look out for whatever the information is there in data.dvc and download the required one. This is how DVC works. And there are a lot of other features as well. Before I cover that, I think it'll be good if I start showing you how DVC works with the project. So to understand the concept of DVC and its features better, let's go through a sample project. In code.switcher.org, I just created a empty repository, cloning it. All right. So for this talk, I've created this sample project. So on an overall level, so data folder contains the data that we need, and this script is essentially pre-processing our data, and this script is training our model based on the data. And next, the script is used to evaluate the model. So this is what we have. We're just copying them and pasting them in our new repository. All right. Next, we go to our repository. Next, we need to initialize DVC. Next, we need to tell DVC what we're trying to track. In our case, we'll be tracking data. Okay, so just as we discussed, DVC generates a metadata file, a smaller version of the data, so that we can give it to Git for tracking. So this is that metadata file. So just have a look what's happening inside. So these are some details that are inside the metadata file. All right. And another feature DVC provides is the remote storage. So this helps in reproducing the experiment anywhere else. So if your teammate is sitting somewhere else and he wants to reproduce it, you can post your data to a common storage server and then he can access it. So in our case, let's do it through Google Drive. So you can also do it through S3 and GCP and a lot of other features, a lot of other service providers. But as of now, since we don't have access to all that, let's use Google Drive. So the way we do that is go to your Google Drive and then create a sample folder. Call it DVC storage. Yeah, once you have that, in the URL, just note down this section of the URL. Next, yeah. So now that we're here, just type DVC remote. And now we're trying to make it as a default remote. Just give a name to the storage, Google Drive storage. Okay. A lot of drive storage, and then so this is the URL you need to pass G drive equals to, and then this. Okay. Let's just DVC remote and let's do this. Yeah, this is right. Okay. So we add the details here. So DVC remote. So we're just adding a remote storage, and then we're saying use this as a default remote storage. Just give a name to it. So I'm just saying G storage, STG. So that's simple. And then you need to mention that you're using a Google Drive. So, and then you post whatever you have. So yeah. All right. So this is set as a default remote. And if you check, we have so these are files that are required for DVC, and then data.dvc is something that's being generated by data.dvc. And then if you look at git ignore, you'll find that data folder has been ignored. So this is added by by DVC because we don't want this folder to be sent to Git. We just want only the metadata to be sent to Git. So that's why it automatically adds whatever you want to track with DVC to git ignore. Okay. So now that we have the data, you can just do DVC push. It will push whatever the data you have to the remote storage. Right. see the link. Okay, so Google Drive needs to authorize DVC to access the particular location. Hello. Hello. Okay. Right. Just copy this and paste the code here. Yep, data has been uploaded. So we can just go to the file storage and have a look. So whatever data we have, so that's been encrypted into these small folders by DVC. All right. So now that we have it, let's understand a few more things. So we just talked about remote storage. Let's talk about DVC pipelines. So DVC has a concept called data pipeline. So whenever you run a machine learning project, there are multiple phases involved: pre-processing, training, evaluation. So for every stage, so you can name a stage. So I've just named this as pre-process. And then for every stage, you have three things that are common, which is the command that you want to run. So which is here Python preprocessing.py, and what does it depend on? So it depends on the data folder and as well as the script itself. And then what is it outputting? So here it's outputting the features. And next, so this is another stage, a second stage called training. So here the command is python training.py, and in fact this stage, the second stage, depends on the first stage. First stage is output, which is features. So the output of pre-process is our input to training. Yeah, so these are the dependencies, and then we have the output, which is essentially the model that we have. And for evaluate function, obviously, so input is the output of training and so on. So this is what we have. You can also visualize what's happening. So you can just do DVC DAG. So this will give this information on what's happening. So it will tell us that these are the stages that are there, and this is the input file. So this is the data we have. So you need to, if you pass this information here, so DVC considers this whole thing as a pipeline, as a project pipeline. And now if you want to run it, you can just do DVC repro. So this is going to reproduce. So if you run it, it's going to run all the stages. So this might take some time. Yeah, that's done. All right. So yeah. Now if you try to run the same pipeline again, since nothing has changed because the input data didn't change, the training script didn't change. When you try to run it, DVC senses that nothing changed, so it's going to skip all of them. So there's no wastage of computation here. So it cleverly understands that there's no change in the data or anything. So it's not going to run all of them again. So that's one benefit DVC provides. All right. Yeah. So the output of evaluate script is essentially this one. So which is providing the output scores. So P stands for precision, R is recall, F is F score. Okay, so we have a lot of information. Let's just call this as experiment 1. .dvc. All right. Now let's just say that's experiment 1. All right. Let's push all of them. Cool. Now let's try to change the data and see what happens if we do that. Also, you can check if any other data has been tracked by DVC. So what I am trying to say here is, so these intermediate features that have been generated, or this output that has been generated, so this model, so DVC automatically tracks these things because these are generated as part of the pipeline. So when you try to do DVC push, so this time it's going to push features as well as model. So you don't have to explicitly mention that features and model have to be added to the DVC, because it understands from the pipeline that these are intermediate files and they also are a part of the experimentation. Right. This might take some time. Yep. So model folder is going to be uploaded. So this will take some time. All right, so 19 files have been pushed. Now that we have all of them, so let's take a look at the scores. These are the scores for the first iteration or the first experiment we've done. For geopolitical entity, we have recall 50, F-score 66. So let's change something in the data to find out if DVC can understand the differences and rerun the pipeline or not. So I've just added another example to the training data. Let's check what happens. So I'm just doing repeat DVC repro. So this is going to run all the steps in the pipeline if there's a change. Yeah. So since there's a change, it's going to run everything. Yeah. So now we can see that there's an improvement in score. So we can store these details as well, saying so second experiment what changed is just the data, nothing else, which can be tracked here. Yeah. And data.log and git push. So just checking again, you can just type python evaluate.py. So it's going to run and give you the scores. So if you want to go back to the previous version, git log. So we have experiment 1 and experiment 2. So if you want to go back to experiment 1 where the F score is 66 instead of 100, you just do git checkout ID. All right. Now that we have moved to the previous branch, we should also do DVC checkout. So this will automatically bring back the older version. So let's just do that. So this is telling us that these files have been modified to the earlier version. So you can just have a look. So yeah, so whatever the line we've added, it's not present here because it's the first iteration of the data. Now, if we want to go back to the actual version or the updated version, which is second experiment, we just switch to the latest version. So let's just do DVC checkout as well. All right, they have been updated, and yeah, in the second iteration we have this new example added. So yes, so that's how Git and DVC work together. Yep, so that's about DVC. All right, we will be talking about the second part, which is the CI/CD for data science. Here we'll be talking about CML, which stands for continuous machine learning. So we'll talk about it in the tutorial part. As of now, so in the first part, we've seen that we're able to version control our data and as well as code, and we're able to like complete a whole experiment and then package it to Git. So once you do that, whenever you push your code to GitHub or GitLab, it triggers. So we can make sure that it triggers a CI/CD file. So when this happens, it triggers a set of actions that are defined in the CI/CD YAML file. So since we're talking about machine learning here, we just want to make sure that given a particular data and a particular architecture and a set of parameters, we want to make sure that we're able to reproduce the experiment and get the metrics. So is it performing better or not? That's how we decide, right? So after we should be able to pull the data, we should be able to install our requirements in the testing environment, and then retrain the model and then get the results. And you can publish the results as a pull request comment, and whenever your team lead sees the metrics and sees a merit in updating the website, he'll approve it, and then your website will be updated with the required changes and the required model. So let's look at a tutorial. So let's get back to the sample project that we're talking about. So in the meantime, I've added two things. First is requirements. So requirements basically is, one second. So yeah, so here we're just installing our required packages. So the reason why we need this requirements file is that we should be able to install our libraries in a testing environment. So testing environment is the base that is provided to us. It is essentially a Docker image. So think of it as a basic laptop given to you on a remote location for testing. So on that remote server, you need to install your libraries and then train and test. So that's where this is useful. So we mention whatever is required. So we just mention them. Then another file that I mentioned is the YAML file, the CI file. So here we mention whatever stages are there. So we just have one stage and we're calling it CML run, and we are using a base image. So essentially this has CML installed in it and Python 3 installed in it. So just like how I told before, the first step is to pull the data from the remote location. So we're doing it with DVC pull data, and then we need to install the requirements into in the testing environment for the training and testing to happen. And then we just type DVC repro. Since we have already run it before, we know that it will run all the stages in a machine learning pipeline. It will pre-process, train, and then evaluate. So DVC metrics is something I haven't talked about. So I'll just give a brief on what it's doing. So if we go back to the same YAML file, so the DVC pipeline file, here apart from these stages, we also mention metrics. So apart from the usual three steps in a stage, which is command, dependencies, and outputs, we also have something called metrics. So when you mention this, DVC will track whatever is inside this file. So it's just a JSON file. So DVC will track this JSON file since we've told that they are metrics. So it's going to measure this file. DVC is going to track this file for us. So in the YAML file, once we've trained and tested, whatever the scores are there, so when we do DVC metric show, it's going to basically give us the same output, which is precision, recurrent, F score, and then store it in a markdown file. So this essentially means convert whatever the output is in terms of a markdown format. And then we just so CML has a set of commands that you can use. So when you type CML send comment, it's going to reflect as a comment. Let me just show you. Yeah. So this is a sample comment that I've done. So whatever changes you've made after that, so CML will automatically publish this thing for you. When you use CML send comment, it's going to send that file in terms of send that markdown file in terms of a comment. So you can actually send pictures as well. So there are just different commands for that. Let me just open it. Yeah. So if you do CML publish, it's going to append an image into the markdown file. And you can also just append any text into a markdown file, and then finally when you want to send it, you just type CML send comment, and then this markdown file, whichever is appending all the data, that's going to be reflected in your comment. So so that's what it's doing essentially. At the end, we are just sending the report.markdown file to as a comment. So let's see it in action, what's happening. So let's create a new branch. Let's call it test CI/CD, test CI. Okay. Now we are in a new branch. So here, let's make some changes. Let's say we just want to change the number of epochs to 10. Or I don't know, 7. Yeah. Now that we've done it, So this has been changed. So just type this params file updated. Yeah, just push. Oh yeah, just let's keep. So as of now, it's just a local branch. So let's just make it a remote branch as well. Cool. So we pushed our changes, which is the number of epochs, this file, whatever we changed. So now this will trigger a CI/CD actions. So you can just go to your repository, then go to branch test CI. So here you can see that your pipeline is running, the CI pipeline that you have initiated when you have clicked on git push. So you can click on it to see the details on what's happening. So yeah, so you can just click on it to see what's going on behind. So you could see that the base image that we've passed, which is essentially DVC or CML Py3. So that is getting prepared. That's getting pulled and prepared. And next, we are pulling the data, DVC pull data, and then we are installing the requirements. And then, okay. Yep. And then we are training, and then we are evaluating. So these are the scores we got. And next, we also published these results into report.md. Let's see where they are visible. So it shows that you pushed to test CI 1 minute ago. Let's create a merge request. Yep. So this is the file that we have. Yeah. So params file updated is what we have. Then we click on create merge request. So whenever your team lead sees, he's going to look at the pipeline. So it says it has passed everything, and then he can also look at the comments. So here it shows everything is 100. Then he might take call to approve your merge request. Yeah, so that's about CI/CD CML with DVC. So some more information, which is when you try to do it. Okay. So some more information is that so when you're trying to do DVC pull, your data is actually stored in a personal Google Drive. So for a testing environment, to access your personal Google Drive, it should be able to have your Google Drive access token. So you can actually access it this way. You can just go to .dvc folder, and then there's a temp folder in it. Just open it. In that you can find this file, Google Drive user credentials. So whatever you find in that, just copy all of the content inside that JSON, and then come back to your project. Now, when you come back to your project, go to, so this is your repository, right? Just go to settings and then click on CI/CD. Now, you can go to variables and click on expand. So in that you can add a variable with the name, so whatever you found in that JSON file, that will be in the value. You don't have to protect or mask it. and then the key, which key is Google Drive credentials data, and value will be whatever you found in the JSON file. You can just have a look here, so whatever is there in the JSON, I just pasted it here, and then this is the key. So this is needed for the CML to let the testing environment access your private Google Drive. Next is the repo token. So this is also required. So the way, yeah, you can just click on it and then type repo underscore token. And for value, you need to create an access token. So just go to access tokens and then create a random thing. Then it should have the scope should be API, read repository, and write repository. Then create a project access token. So whatever the token is given to you, just copy it and then go back to your CI/CD variables and then repo token. Whatever you have, you just paste it here and then save it, and it should be masked. So these are the things that are required for your pipeline to pass without any access restrictions. So yeah, so that's the last detail I wanted to add, and thank you.